Friends, today we are going to discuss evaluation of double integrals. First, let us look how the double integral looks like. A double integral might look like this. Integral a to b, integral m to n, some function of x, y, dx, dy. Or it may look like this. Integral a to b, phi 1 y to phi 2 y, f of x, y, dx, dy. Or a double integral might look like integral a to b followed by integral phi 1x to phi 2x, f of xy, dy, dx. I want you to observe here a few points. The first point, outer limits of outer integral are always constant. Here see, this is outer integral, limits are constant. Here outer limits are constant. Here also the outer limits are constant. In case number 1, if you observe, case number 1, the inner limits are also constant. In case number 2, if you observe, the inner limits are functions of y. And in case number 3, if you observe, inner limits are functions of x. Alright? When the inner limits are functions of y, then those are considered as variations in x. So x is varying from phi 1y to phi 2y. Similarly, here I want you to understand if inner limits are function of x, then those are basically variation in y. So y is varying from phi 1x to phi 2x. So a double integral will be looking like case number 1, where both outer as well as inner limits are constant. Or it may look like this, where outer limit is constant but inner limits are functions of y. Or it may look like case number 3, where outer limit is always constant but the inner limits are functions of x. So based on these 3 different cases, we decide the order of integration. So now I'll take examples for each of these cases and explain you the idea of order of integration. So let me take one simple example. Integral 0 to 1 followed by another integral 0 to 1, let's say x plus 2 dx dy. Fundamentally, keep this point in mind. We should always integrate the inner integral first. Okay. So first thing I notice, both the limits of integrals are constant. So here order of integration doesn't matter much. When I say it doesn't matter much, what it means, let us understand. Here somebody would say I'll integrate with respect to x first, and having done that, then I'll integrate with respect to y first later on. That is perfectly fine. Somebody else might say that, hey, I'm going to integrate with respect to y first, and having done that, I'm going to integrate with respect to x later on. That is also perfectly fine. So that is why I say when both the limits, outer as well inner limits, are constant, then the order of integration depends on your choice. Let's now look at this question. This one is my inner integral, right? So I'll evaluate the inner integral first, keeping the outer integral as it is. Alright? So inner integral will be what? Integral of x will be x squared by 2 plus integral of 2 will be 2x, and this is between the limits 0 to 1. So it is integral 0 to 1. Outer integrals are as it is. I put the upper limit, so I'll get 1 by 2 plus 2 minus I put the lower limit, that is going to give me 0. So this is going to be integral 0 to 1. This is 5 by 2 dy, and now this is very simple, right? This is going to be 5 by 2 integral y between 0 to 1. Let us put the upper limit, that is 1, minus lower limit, that is 0. So the answer is 5 by 2, right? Let me take one more example to put this point across. Suppose I have integral 0 to 1, integral 0 to 1, 1 by root of 1 minus x square, root of 1 minus y square, and I can see dy dx, right? Notice both the outer as well as inner limits are constant, right? So let me first evaluate this inner integral, which in this case is with respect to y. Can you see? This is with respect to y. So I evaluate the inner integral first, keeping the outer integral as it is. Now when you look at this inner integral and you want to integrate with respect to y, keep in mind when you are integrating with respect to y, you have to consider x as constant. While integrating with respect to y, you have to consider x as constant. So this term of x, I consider it as a constant, and if it is a constant, right, so I can shift it outside, right, because this whole term is constant multiplied to this function, right? So I'll shift the constant outside. So this is going outside. I'm left with integral 0 to 1, 1 by under root of 1 minus y square dy, right? Now this is my inner integral. So in the next step, this is going to be 0 to 1. This is as it is, right? And this is going to be sine inverse of y between the limit 0 to 1 dx. All right. So let us put the upper limit over there. So if you put this upper limit here, you'll get sine inverse 1, which is pi by 2, minus put the lower limit, which is sine inverse 0, which is 0. So pi by 2 minus 0, can I directly write it as pi by 2? And pi by 2, once again, now is constant. I can keep it outside. So it goes outside. And what is integral 1 by under root of 1 minus x square? That is sine inverse of x, right? Between the limit 0 to 1. So here also let us substitute the upper limit and lower limit. So it is going to give me sine inverse 1, which is pi by 2. Put the lower limit, sine inverse 0, which is 0. So the final answer is going to be pi square by 4. Right? So I hope you understand the first case where both the outer and inner limits are constant. Now let me take you another example where outer limit is constant, you can see, and inner limit is function of y. Okay, wait a minute, let me correct the question slightly. Yeah, here outer limit is 0 to 2 and inner limit is function of y. Yeah, like this. Oh, slight correction. Outer limit is 0 to 1 and inner limit is 0 to y, and I have got, let's say, xy e raised to minus x square dx dy. Now observe here, we know outer limit by default is always constant, but here you observe the inner limit is function of y. That means these are variations in x. So x is varying from 0 to y. That means as far as inner integral is concerned, it is to be carried out with respect to x. Now here order of integration matters. Here you cannot change the order of integration by your choice. Previously, when both the limits were constant, you had a choice, right? Now you don't have a choice here. Since inner limits are functions of y, that means these are limits of x. If inner limits are functions of y, that means these are limits of x. And if these are limits of x, then we should first integrate with respect to x. And after having done that, after completing that, then we have to differentiate with respect to y. So here the order of integration is rigid, right? So let's first now try to integrate with respect to x. Alright, for that outer limits are as it is. And when I'm integrating with respect to x, please understand this y term will be constant. So I can keep it outside. So it will be simply x is equal to 0 to y. It will be x into e raised to minus x square dx dy, right? My intention is to evaluate this integral first, right? To do that, what I can do is I can substitute here x square as t. So I'll get 2x into dx, which is equals to dt. Can you see here x into dx? So I can adjust x into dx, which is going to be dt by 2. Right? And also I should change the limits of integration, right? After substitution, that is very important. So x limits are from 0 to y. So what will be t? So when x is 0, t will be 0 square, that is 0. And when x is y, t will be y square, right? So these are the new limits, right? So let me proceed further. Outer integral 0 to 1, y as it is. Now inner integral will be t equals to 0 to y square. This x into dx will be replaced by dt by 2, and this will be simply e raised to minus t, right? Because x square is t. And of course you have dy. Please understand all the action is going on here in the inner integral. All right, so here this 1 by 2 dt upon 2, which is 1 by 2, I can totally keep it outside. So this will be integral 0 to 1 y. Right now this integral would be what? It would be e raised to minus t divided by coefficient of t, which is minus 1. So it is divided by minus 1, and the limits are from t equals to 0 to y square dy. This minus also I can keep it outside the integral, right? And when we put the upper limit over here, it is going to be e raised to minus y square. All right, and when you put t equals to 0, so it is going to be e raised to 0, which is 1. So this is what I'm going to have, right? So it is going to be minus 1 by 2 times integral 0 to 1 y into e raised to minus y square dy minus integral 0 to 1 y dy. I hope now these two are very simple integrals which you can evaluate on your own, right? This will be what? This will be y square by 2 between the limits 0 to 1. And as far as this is concerned, again you can substitute there y square as not t, you can take theta and proceed further. All right, so I think these two are simple integrals which you can self-evaluate. Now let me take one more example. Here I would like to take this example now. Integral 0 to 2, integral 0 to root 2x, xy dy dx. All right. Observe here, outer limits are always constant. There is no doubt about it. But look at these inner limits, right? These inner limits are now function of x. When inner limit is function of x, that means it is variation in y. When inner limits are variation in y, that means the order of integration is now fixed. Here I have to integrate with respect to y first, and having done that, then I'll integrate with respect to x. I repeat what I said. Here inner limits are functions of x. That means these are limits of y, variation of y. When inner limits are function of x, then these are values of limits of y. So we should integrate with respect to y first. Here the order of integration is rigid. You don't have a choice. So let us integrate. So it is outer integral as it is. Now I'm integrating with respect to y. So this guy x is constant. So let it be as it is. So integral of y will be y square by 2 between the limits 0 to root 2x, right? Dx. 1 by 2, I can totally keep it outside, right? It's 1 by 2. So this is 0 to 2x. Put the upper limit. If I put the upper limit, then this will be simply 2x. Minus 0 will give me simply 0, right? So ultimately, I'm going to get 0 to 2. This will be x squared dx. Again, now this is very simple integral. That is x cubed by 3 between the limits 0 to 2, which we can easily calculate. So friends, I hope you understand the basic idea of evaluating double integral, right? So let me quickly recap. What are the important points? See, when both the limits of integrals are constant, order of integration doesn't matter much. For example, here, as far as given integral is concerned, it is saying you integrate with respect to x, and then you integrate with respect to y. But if I wish, I could write it as integral m to n, integral a to b, fx dy, dy dx. Means I switch the order, right? Both the limits were constant. Inner integral was with respect to x, and outer integral was with respect to y. So here, first I would integrate with respect to x, and then I would integrate with respect to y, right? But since both the limits are constant, the order of integration doesn't matter much. So if somebody wants to switch the order, no problem. So switch both the integrals around. So here now you can see, now I would integrate with respect to y first and then with respect to x. That was point number 1. The important point number 2 was, when inner limits are functions of y, when inner limits are functions of y, then order is fixed. Why? Because if inner limits are functions of y, then those are limits of x. So you have to first integrate with respect to x, followed by integration with respect to y. Here you do not have this luxury of switching over the order, right? And similarly, in third case, outer integral is constant and inner integral is function of x, right? When inner integral is function of x, what I said, these are limits of y. And if these are limits of y, you have to integrate with respect to y first, and then you have to integrate with respect to x later. So I hope using these examples and using this discussion, you have clearly understood the idea of order of integration, which is very important in evaluation of any double integral. I'll catch you later. Till then, bye-bye, take care, and stay connected.